Hello, my name is Matt Harden, and today I'm going to give you a short presentation on EPHs, also known as Extractable Petroleum Hydrocarbons, and the biotage solution for that, the ISOLUTE EPH cartridge. So this is a little bit about me to give you a background on where I'm coming from in the industry. I've got about 6 years in environmental sciences, everything ranging from identifying fish populations to selling and setting up air quality monitoring equipment. 3.5 of those 6 years were spent at a commercial testing lab where I started out on extractions, performing liquid-liquid extractions and microwave extractions for a variety of different compounds and tests. I later moved on to the analysis of these extractions, performing methods such as EPA 625.1, EPA 608.3, EPA 8270, and the Mass Department of Environmental Protection's EPH method. My current role is an application chemist at Biotage, and I've been in this role since September 2019. And since then, I have learned a lot about the SPE side of extractions and the automation of extractions. So here's a quick background of extractable petroleum hydrocarbons. One of the first methods developed to characterize these was the Massachusetts Department of Environmental Protection method, and that was later adopted and adapted by other state agencies and countries in order to characterize and analyze these compounds. They present a major global problem due to leaking underground storage tanks that will leach off hydrocarbon materials such as fuels, lubricating oils, and crude oils into nearby soil and water sources, which can lead to health risks. With that said, the analysis of both soil and water is a significant business to monitor contamination levels, understand the toxicological impact, and measure the effectiveness of soil remediation projects. As I mentioned in the previous slide, the Massachusetts Department of Environmental Protection was the first to use a petroleum fraction approach when characterizing and evaluating health risks associated with petroleum contaminated sites. That fraction approach involves the splitting of the final sample extract into two distinct portions, the aliphatic and the aromatic fraction, and that allows us to better characterize that contamination. Another big method is the one developed by the TPH Criteria Working Group with assistance from Shell, and it is loosely based on EPA method 3611, which is alumina column cleanup, and EPA method 3630, which is silica column cleanup. Below is just a list of some of the other organizations that have developed their own approaches to the EPH extraction. Those are including Connecticut, New Jersey, Texas, Florida, Alaska, and Washington State, among others. Something that I'm intimately familiar with is the quantitative analysis of EPH, which I've performed well into the thousands of. Those sample fractions that I spoke of in the last slide, the aliphatic and the aromatic portion, are analyzed by dual GCFID, which is a flame ionization detector. They have dual columns and dual detectors that allow for both the aliphatic and aromatic fractions to be analyzed on the instrument concurrently, and that data is then sent to the computer where you can quantitate it and report it to whatever agencies you must report it to. However, some water permits have lower detection limits and require a little additional analysis, and that can be done via GCMS selective ion monitoring or HPLC to demonstrate compliance with these permits. So with the background of EPHs out of the way, now let's move on to the topics for discussion for today's presentation. First, I'll be giving a brief overview of the ISOLUTE EPH. Then I will be discussing the benefits of using it, how to use it, and how to optimize time when using it, because as we know, time is very important in the lab. First, before we move on to the overview of the product, I'd like to bring up some questions to think about during this presentation. Does our lab have a problem with naphthalene breakthrough? How disruptive is refractionation to our workflow? How consistent are the solvent volumes from batch to batch of fractionation cartridges? How much solvent do we use during fractionation? And how can we reduce the time associated with EPH extractions? Now, I'm going to bring these back up at the end of the presentation, and hopefully I have answered all of those questions for you. Now here is an overview of the Biotage ISOLUTE EPH cartridge. It is an optimized and proprietary blend of silica and alumina that helps to split a complex mixture of petroleum hydrocarbons into aliphatic and aromatic fractions. It provides clean and robust fractionation and, most importantly, batch-to-batch consistency. The 3 ml cartridge has been further optimized to significantly reduce size without sacrificing any reliability. This allows for further reduction in solvent use and also allows for automated fractionation, which we will discuss later in this presentation. These next few slides will give some examples of some of the chromatograms that come out from the analysis of extractable petroleum hydrocarbons. This first slide is an example of a pre-fractionation EPH. As you can see, there are a lot of different peaks that are all closely bunched together, which can cause some issues in identifying the contamination. On this slide, you will see the impact that fractionation has on the sample. Now, this is a chromatogram for the aliphatic portion, and as you can see, there are nice distinct and sharp peaks that are nicely separated from each other, allowing for better characterization of that contamination we've been talking about. Similar to the last slide, on this one you can see a much clearer chromatogram as well as nicely defined peaks for the aromatic portion after you have fractionated the sample. One of the terms that I've been using in previous slides is breakthrough. Now, what is breakthrough? It is the loss of naphthalene and 2-methylnaphthalene, which are aromatic compounds, as well as the fractionation surrogates into the aliphatic portion of the sample extract. This occurs as a result of too much solvent being used, which can leach those aromatic compounds into the aliphatic portion too early. It can also occur when there's moisture in the cartridge or from overloading the cartridge with too much material. If it is observed, refractionation must be performed, which requires you to start the fractionation process from the beginning for that one particular sample. This is both time-consuming and disruptive to the workflow, especially if it occurs on a control sample, which can hold up an entire batch of data that needs to be reported. Naphthalene is the main indicator of fractionation efficiency. So when we're looking for a good cartridge, we want it to be very good at retaining naphthalene so we can reduce or eliminate the issues with breakthrough. In comparison to other cartridges, the Biotage ISOLUTE EPH more efficiently retains aromatics to reduce breakthrough by utilizing a smaller particle size. Now, to prove to you that our product is more efficient at retaining aromatics and most importantly naphthalene, I will be running through a little naphthalene retention test for you over the next few slides. Both of these tests will utilize a proprietary blue dye to mimic the behavior of naphthalene on the cartridge media. The first test is the 25 ml ISOLUTE EPH manual test. That will compare our 25 ml cartridge versus a similar competitor cartridge. This will be performed using gravity to elute the cartridges, which is by far the most common way of fractionating a sample. The second test will be the 3 ml ISOLUTE EPH automated test. That will compare our 3 ml cartridge versus a similar cartridge from a competitor. This will be performed using an automated extraction system. So if you look at this picture on this slide, these are the results from comparing the ISOLUTE EPH to the strata from Phenomenex for the manual test for naphthalene retention. On the left, you will see a sharp, well-retained tight blue band, which indicates good naphthalene retention and fractionation efficiency for our cartridge. Comparing that to the right two cartridges, you'll see those have diffuse bands, which will indicate poor naphthalene retention and fractionation efficiency. Here we can see the results of the automated naphthalene retention test using our 3 ml ISOLUTE EPH cartridge and comparing it to the Varian brand cartridge. On the left, we again see a nice tight blue band which indicates great naphthalene retention and great fractionation efficiency. On the right, we see another diffuse blue band that is seated very low on the media that indicates poor naphthalene retention and poor fractionation efficiency. So here I wanted to take a second to go over the two options that we have for the ISOLUTE EPH cartridges and how they come from Biotage. The first one associated with the manual method is the 25 ml SPE cartridge that comes 20 per box. The second one commonly associated with the automated method of fractionation is the 3 ml SPE cartridge that come 50 per box. Now let's discuss how we actually use the ISOLUTE EPH cartridges. This is going to be an overview of the manual fractionation method utilizing a manual manifold, which is depicted in the picture on the right. I'm sure many of you in the lab are very familiar with this. I know I certainly am. This will be using our 25 ml ISOLUTE EPH cartridge. The sample will either be a soil or aqueous extract in hexane. And before we load that sample into the column, we have to first condition it with 20 ml of hexane. We allow that to flow under gravity until the solvent is just above the top of the frit, and then we can load the sample on. So we load the sample on, and then once that reaches the top of the frit, we add 12 ml of hexane and allow it to continue to flow under gravity. What we collect from there will be the aliphatic fraction, and then we will add 20 ml of DCM, allowing it to flow under gravity once again. And what we collect from there is the aromatic fraction of the EPH sample. Before we move to the automated side of things, I just wanted to highlight a very cool feature of our product. What you're seeing here is a screen capture of part of our QA report, and it's highlighting a few of the tests that we perform prior to sending out these cartridges to you. The most important of them all is the aromatic and aliphatic fractionation check. When you're in the lab, you have to run a fractionation check before you test any samples with a new batch of fractionation cartridges, just to ensure that everything is clean, everything's up to par. This saves you some time in the lab that Biotage has assured you that we have already completed a fractionation check and what we are sending you is of the highest quality. Another important test that we run is the column and frit purity checks, just to ensure that there's no extra contaminants in our cartridges for you. When looking at competitor QA reports, they fail to provide the same quality tests as we do. With that said, let's move on to the automated method overview. On the right, you'll see a picture of the Biotage Extra Hero, which is a fully automated extraction system which is capable of performing supported liquid extraction, solid phase extraction, phospholipid depletion, and protein precipitation-based methods in either plate or cartridge format. Obviously, for this application, we are focusing on solid phase extraction and cartridge formats. The SPE column we will be using is the ISOLUTE EPH 3 ml cartridge. Much like the manual method, we will have a final sample extract of a soil or aqueous sample in hexane. And now, being that this is an automated system, all of the conditioning, sample loading, aliphatic elution, aromatic elution, and post-elution will be pre-programmed into the instrument, allowing this to be completely hands-off for you. Much like the manual method, we will condition the column, then apply the sample, and then elute this aliphatic portion, elute the aromatic portion, and then collect them both into collection vessels for analysis afterwards. Here we're going to look at one of the biggest benefits of automating the fractionation process, and that is the reduction of solvent use. In this table you can see the ISOLUTE EPH manual method, the ISOLUTE EPH automated method, the Mass Department of Environmental Protection method, and the TPH criteria working group method, and all of the required solvent for each of those specific methods. As you can see, the manual method improves a lot on some of the other traditional methods, like the Mass Department of Environmental Protection and TPH criteria working group method. The ISOLUTE EPH automated method takes that one step further and significantly reduces the solvent volumes even from that of the ISOLUTE EPH manual method. Now, solvent volumes are significantly reduced via automation, and that will save cost, reduce waste, and reduce time investment because you won't be spending as much time watching solvent drip through a cartridge. Here are some more advantages of automating EPH fractionation. Now, you might want to be sitting for this first point because I was certainly blown away when I first heard it, but you can improve productivity in the lab by fractionating 24 samples in roughly 40 minutes. I don't know about your lab, but from my experience, fractionating 24 samples would probably be an entire day and a half of just fractionating and getting nothing else done. That is a crazy reduction in time spent in the lab on fractionation. We also have the dramatic reduction in solvent use and cost, as we discussed in the last slide. We also eliminate evaporation of the sample because it's not sitting on the cartridge for so long like in the manual method, which leads to higher productivity, improved method performance, and it also reduces solvent blanks and associated MDLs. You also reduce consumable costs, and at the bottom of the line, it enhances the profitability of EPH analysis for your lab. So you might be asking, why is the ISOLUTE EPH so important to Biotage as a company? Well, for one thing, it was the first dedicated environmental testing product from Biotage for many years. Previously, they focused more on the biopharma industries. This helped signal the refocus of Biotage on the environmental science sector. And this refocus in turn led to the acquisition of Horizon Technology, who have acted as the environmental experts of Biotage and have contributed greatly to the recent success of Biotage as a whole because it allows them to have a completely dedicated environmental testing product line. So now let me summarize what I've gone over in today's presentation about the ISOLUTE EPH cartridge. The ISOLUTE EPH has been optimized to ensure there is no breakthrough of the aromatic compounds into the aliphatic hydrocarbon fraction, as well as preventing breakthrough of high molecular weight aliphatic hydrocarbons into the aromatic fraction. This is important because, as we discussed on previous slides, issues with breakthrough and having to refractionate samples are very disruptive for a lab's day-to-day operations. Sorbent mass, composition, and associated methodology have been optimized to achieve efficient fractionation while minimizing solvent volumes used in the fractionation process. The cleanliness of EPH column components are fit for purpose. The QC of the ISOLUTE EPH has been tailored to cover these key features as well, and one of those key features was that the COA comes with fractionation check data, which helps save some more time in the lab. Now, coming from someone who has used this product in the lab before coming to Biotage, it was certainly a lifesaver to help reduce some of the headaches associated with fractionation and got me out of the lab and back to analyzing data and getting customers happy. So the EPH ISOLUTE cartridge was a huge win for me. As I mentioned earlier, I was going to bring the questions to think about back up at the end of the presentation. Hopefully, throughout my presentation, I've answered all these questions for you, but I'm going to leave this up for you to review and see if you have any more questions. That is all that I have for you today. Thank you for viewing.